Welcome to the vibration lab. We are in the front of spring mass system. This is one of the simplest experimental demonstration we generally perform to understand the basic philosophy of vibration. Here you can see there is a spring, and from the spring this body has been suspended. Now if we will think an equivalent system which oscillates, so here we can find that there is a spring and there is a mass. Whenever you are having a spring and mass, the system has capability to exhibit vibration. Why? Because the mass act as an inertial member and the spring act as an restoring force member. Please understand and remember also that whenever you want some system has to vibrate, these are the two basic element which must be present in your system. One is the mass, another one is an agent which supply the restoring force. For example, if you think about a pendulum, in case of pendulum, the bobs serve the purpose of mass, but their gravitational force is responsible for the restoring force. So in this demonstration, what we are going to perform, we want to find the natural frequency of this system, because whenever you are having vibration, the system exhibits vibration and you can measure the frequency of oscillation. Now I am saying the natural frequency. What do you mean by natural frequency? Natural frequency means when your system vibrate freely. For example, if initially I am giving a disturbance to my system and then it is vibrating freely, now I am not applying any force on my system. So this is the state of your system where it is exhibiting free vibration. And the system has naturally it's a natural for the system that it possesses one natural frequency. So this is the natural frequency of your system. Similarly, if you will give oscillation to a pendulum, the pendulum will exhibit a vibration with certain fixed frequency, and that frequency is independent of the initial deflection amplitude. For example, for this system, if I will give very small deflection and I will measure the frequency of oscillation, and in other case if I am giving a large deflection to my body and I am going to measure the frequency of oscillation, in both the cases the system will have same natural frequency because it's a property of your system. So the objective of this experiment is to find the natural frequency of system experimentally, and then you have to compare it theoretically. Now to measure the natural frequency experimentally, what you need to do, you have to simply give an oscillation to your system and then you have to measure the oscillation frequency or oscillation time period with the help of a stopwatch. Then you have to cross check this experimentally measured time period with the theoretical time period. Now the question arises that how you will get the theoretical time period. So we have a standard formula where you can put the mass value and the stiffness value and you can get the natural time period of this system. But in this case you have to measure the mass of this body and then you have to find the stiffness of this spring. Now the question arises that how you will get the stiffness of this spring. So to get the stiffness, we can apply the law of statics, in that initially we will remove this mass from the spring and we will measure the unstretched length of our spring. Then we will put this mass on the body and again we will measure the stretched length of your spring. Then you will be having the extension in the spring using the simple formula Kx is equal to F. You will get the stiffness of this spring. So I am just concluding that what you need to do in this experiment, first you have to measure the natural frequency of your system experimentally, and then you have to compare it with the theoretical data. And theoretically you need the spring stiffness and the mass, then you will get the frequency or the time period of this system. Thank you.